All right, welcome. John is not with us this week, so I am Luke Tillman, and I'm a technical evangelist for DataStax. So I'm going to be running This Week in Cassandra for this week. And with us today, we have Patrick McFadden, who is the chief evangelist for Cassandra at DataStax, and also Joel Knighton, who we're super excited to have. He's going to talk to us a little bit about Jepsen testing with Cassandra. He's also a DataStax employee. So, you guys probably, if you've listened before, you know how this works. We kind of go through some of the blog posts that are linked to from the Planet Cassandra blog post, and there were two that we kind of wanted to take a little bit of a look at. So the first one was this blog post talking about getting started with Spring Boot and Cassandra. So Spring, super popular in the Java community. I'm sure if you're a Java developer listening to this, you know exactly what I'm talking about when I say Spring Boot. And Patrick, you were kind of excited a little bit about this sort of, I don't know, kind of how-to on how to get started with Spring Boot and Cassandra.
Well, I mean, yeah, and it's not just people excited about it. They're like, you're either Spring Boot or you're not. No, it's that inversion control framework stuff that's pretty cool. But I think, just in general, Spring has got such a good following in the Java community. But I think it is not as well known that Spring Boot includes native support for Cassandra, and that's pretty cool, especially when you use Spring Data, and that's been around for a while.
Yeah, I didn't realize that the Spring Data support was there. I know I've heard Jui has a competing sort of mapper implementation, Achilles. But if you're used to using Spring Data, this looks pretty cool. Like this looks like I didn't even know this actually worked. So.
Yeah, the blog post is really neat. First of all, it starts out on the right foot because he's using CCM to build a small cluster, which I thought was awesome. Yep. And then. From there, it's just real simple. It's a very short blog, but you can get a quickly operating and powerful application running in Spring with full Cassandra support.
Yep. Yeah, pretty good getting started. So if you're a Java developer, especially if you're new to Cassandra, definitely check this one out.
Absolutely, yeah.
Okay, so the other blog post then that we wanted to talk about was this post on the Smack stack. So it's talking about how to get started on DCOS. Which I didn't realize, but DCOS is what's actually powering Azure Container Service that just went, Microsoft just announced that Azure Container Service coming out of beta, and this is sort of the thing under the covers that's running it. But anyway, I think we wanted to talk more specifically about the Smack stack because this is something that we're seeing a lot of people out in the field showing interest in, and lots of deployments. And Patrick, again, you've talked a ton about this. I know you've got a talk even that you gave, I think at the Cassandra meetup group out there in the Bay Area about this.
Seems like I'm talking about a lot. So, all right, pop quiz. All right, I'm going to put. So, Joel, I'm going to put you on the spot. All right, what does SMAC stand for?
All right, I'm going to go for this. I've never run it in production. Doing this live.
All right, here we go.
Not even cheating. Don't even have the blog post up.
That's great.
Arc.
Yep.
Mesos.
Yes.
Akka, Cassandra, Kafka. Did I get it?
Winner.
Oh! It's like first shot. Yeah.
I knew I was here for something.
Yeah. I think a lot of people get tripped up on the Akka part, and sometimes Mesos a little bit, because they don't think of these things all kind of fitting together, but they do. So yeah, those are 5 letters that really is put together in a way that makes up a data pipeline. So if you think of all the needs that you have, it's the whole it's to collect, organize, process, and store. So the collection is the Kafka part, or the organization is Kafka as well. Organization could also be an Akka, but the processing is an Akka, Spark streaming, and then Cassandra for the collection or for the storage. Why these seem to fit together really well is because they all scale the same way. If you need more, you just add more nodes, and it's starting to be a thing because let's face it, we have so many choices as an industry to process and store and organize data. And it's nice when you can get something that other people are using. It minimizes the amount of time you have to think about it and just do it.
Yeah, and all open source tools too, which is pretty cool.
Yeah, all open source. And everyone except Akka is an Apache project, which I think is really cool. Yeah.
Yeah. And so do you see people doing this for not just like streaming pipelines, but also like, since you've got Spark, you're even capable of doing like batch analysis on the back end. Like, I mean, this is partially for real-time sort of data ingestion and calculation, stuff like this, but you're not limited. It's kind of a flexible architecture where you could do either or.
Well, you don't have to use all of the parts at the same time. What it is it's a toolbox of parts, and when you need it, you need it. But I think the best part of it is that it's just, we already have some predetermined organization here. So if you need to learn more about, let's say, how to process data in Cassandra using Spark, there's a wealth of information about that. I mean, we talk about that all the time. If you need to understand how to ingest Akka from Kafka into Akka, wealth of information in there. So you're not just making it up as you go along. And in 2016, you really should.
Yeah, yeah. And so one other thing to mention, I don't think it's linked on this particular blog post. Maybe we'll put a link in the Planet Cassandra blog post. But we do actually have a demo that you, Patrick, and Helena Edelson, the awesome Helena Edelson, put together. That's kind of like at least 3 of these parts. I think maybe even 4 of these parts of the SMAC stack put together, called Killer Weather. That's on GitHub. If anybody is interested in kind of seeing like how it all kind of fits together, we have a demo available as well. So definitely check that out.
Yeah, well, Helena is. I give her all the credit for the code in there because she is such an amazing Scala programmer, and that code is production ready at a scary level.
Yeah. Okay, so we'll kind of segue now. We've kind of covered the blog post. We'll talk a little bit to Joel about what it is he does at DataStax and Jepsen and that kind of thing. So, Joel, maybe start by just telling us like what is your job at DataStax? What do you do? What is it you work on?
Yeah, so at DataStax, I work on sort of the Apache Cassandra open source team. So that's by and large where I spend most of my time, fixing bugs, working on features, really trying to push open source Cassandra forward. But one of the things I've also picked up alongside that is a lot of focus on the tools we use to test Cassandra and how we can make those tools better or just use the tools we already have better.
So I know in particular one of those, kind of part of that role is working a lot with Jepsen. Could you explain, like, what is Jepsen for somebody who's listening out there and has no idea, what I'm talking about when I say Jepsen? What is Jepsen, and how does that sort of apply to Cassandra or your job working on Cassandra?
Sure. So Jepsen's a lot of things, and I think that's kind of one of the first things to establish in this discussion is you want to make it as productive as possible. Is there's really 4 things I like to think of as Jepsen, and I'm going to make it clear which one I'm talking about here. So there's a series of talks that Kyle Kingsbury has given on how he tested these distributed systems. There's some blog posts, there's some tests written for this framework, and then there's the core framework itself, and that's what I've worked with. And the core framework of Jepsen is this closure library that has these facilities to make it easy to test distributed systems under a variety of failure conditions. So when you're testing a distributed system like Cassandra, part of what makes Cassandra so attractive is that we want it to be resilient to these real-world failure conditions. We want it to scale well and remain operationally simple under the sorts of things that happen in real data centers. Network partitions, hardware failures, and we want to ensure your cluster is healthy and correct throughout all of those expected and unexpected conditions.
I was going to say here that Joel, you and I talk about this often, but it's something that whenever we talk to new users or people who are experienced in this field of working with large-scale systems, that original blog post, Jepsen blog post about Cassandra, comes up all the time, and it's a few years old now at this point. I think it's probably worth saying, this is really the reboot of that. Would you say? I mean, taking that and going much further. How would you characterize it?
Yeah, so reboot is an interesting word. I think that blog post is a cool artifact of a trend that was happening at the end of 2013 and into 2014, was this increasing awareness of how we could understand, analyze, and test distributed systems. And and bridging that gap from sort of the academic applications to the practical applications. And that blog post is sort of an artifact of where that was in time and where Cassandra was in that time in that specific set of tests. So what my interest in here is, as someone who learned a lot about distributed systems during that time, to bring that up to modern Cassandra, to bring it up what we have, to turn that from an idea of how you could understand one thing at one point in time under one set of conditions and take all of the best parts of how we can understand distributed systems now and make it part of how we develop Cassandra. Keep it up to date. Keep running those tests. Because as any developer knows, you know, what one run of tests, one set of tests is only part of how we're going to have this continuing development of a system, especially something as large as Cassandra.
So I was, you know, when I talk to, people, you're right. I think people are way more savvy. Developers are way more savvy about, you know, they know what serializability is now. When 4 years ago, they didn't, and they weren't thinking about that, because when we use relational systems, ACID gave us this sort of comfort zone. You know, when you say commit rollback, you know what you're getting, right?
Although I would note that even then, I don't think everybody understood or fully grasped those bumper rails as well as they might have thought.
I think you're probably right. I think you're really right.
You know, it's confusion about NoSQL databases is not peculiar to NoSQL. It's an artifact of the fact that they're complicated systems with complicated jobs.
That's true, yeah.
Yeah, to your point, I think like a lot of people don't like. There's this whole other thing about transaction isolation levels, and yeah, there's this whole other thing that I think most developers probably don't even think about when it comes to relational databases. So I think I probably agree with you when you say it's not unique to Cassandra, this sort of problem.
Yeah.
So, Joel, you work for DataStax, but you're really focused on making Apache Cassandra strong. I mean, can you talk a little bit about the process of your testing, but then how it turns into something in the community that everyone could benefit from?
Yeah, sure. So these Jepsen tests that I have that are updated for modern Cassandra and the modern Java driver and all that are up on GitHub, and they are open source, and there's something we run as we try to understand new features we're developing or increase our confidence in features we already have. So that's sort of where I'm at, is that really these benefits benefit core Cassandra. And at DataStax, I'm really invested in core Cassandra as only one component of the things that we can offer in DataStax Enterprise. But those benefits alone aren't isolated to what DataStax is building on, and really are, I think, important to anybody who wants to have confidence in their database. And I think as someone who has occasionally, under mistakes of my own or mistakes of other, been responsible for databases in production, that's something that helps me sleep better at night.
So you said, you know, as we're like rolling out new features and things like that, these tests come in handy. Can you think of a time, you know, I'm thinking maybe of materialized views was a feature where these tests like came in super handy at finding failure cases. Can you talk about like maybe some time where recently where you know, having this suite of tests or having your work on Jepsen has been like super helpful?
Yeah, totally. So I mean, sort of in the stabilization of 3.0 in general, as we prepared for release, it was kind of useful across the board. But again, with, as you mentioned, a big new feature like materialized views, it becomes really valuable. So let me step back just a little. I've made it clear that Jepsen is this framework we can use to write tests for a distributed system, but I don't think I've really highlighted its strengths and the type of testing it does. So when we're testing Cassandra, we have a bunch of unit tests in tree that are really good for testing specific parts of the storage engine, specific parts of request coordination, as you would expect out of unit tests, but are under the regular constraints of unit tests, and that they might not accurately, you know, really model the system at large. And we have something called D-tests, which are also open source, that spin up a real local Cassandra cluster using CCM, as we mentioned in the first blog post, a really great tool as a Cassandra developer, and run real integration tests against that. And those are really useful, and as has been pointed out in many studies, really sufficient to catch a lot of sorts of bugs you'll find in development of distributed systems. A lot of them really can be found through targeted exploration of specific paths with small cluster size. But on top of that, you kind of have this gap Jepsen can fill, where you're doing randomized black box testing of a system with injected failures. And so when you're developing a big new feature like materialized views, you might not be familiar with the ways it can interact with the sort of failure modes that you might have seen through history in an older feature that's not sort of this brave new world. So when you really want to gain confidence in that, I think randomized testing can really increase confidence in a feature because it explores a far larger component of the state space, and it also makes it clear how that feature will interact with the system at the boundaries where users are using it. So when you do this black box testing, you also have to gain understanding of how the feature interacts with these really cool modern driver implementations that are really sophisticated systems on their own. So I think it really increases confidence in how a user will see a feature and also the ways we'll see a feature develop and be used in the real world.
I was going to say, man, the type of testing you're talking about is that kind of testing that is really almost silent, because it's not what people think of. You know, when you think of a test like a unit test, oh, there's a pass-fail, but those really, I use the word Heisenberg. You know, distributed systems are the classically hard problem when it comes to troubleshooting problems, because you have no idea what system is affecting another system. So I always think of you as like the unsung hero in the back, you know, like the special forces or SEAL team or something, quietly knocking out bugs that no one ever thought of in a million years.
Yeah, and that's one of the things that's one of my favorite part of Jepsen's design, and I think something Kyle did really well in building this library we can use, is that when you're running this test, it's recording your observations about the state of the environment and the state of the system and the operations you're using to modify it to this history. And you're actually checking that history at the end. Because when you find a bug in a distributed system, especially a bug that's evaded regular unit testing or integration testing, it's usually pretty sophisticated, if not in its underlying cause, in its presentation, and as a result of these really sort of complicated, specific interleavings that you're finding through this randomized testing. So if you don't have this big log of all of the operations you've performed, good luck finding it again, good luck reproducing it again. So when we run these sort of tests, it's really nice because it's a lot harder to dismiss them as, oh, this might have been an environmental failure, or this might have been this or that, because you really can go dig in and find the root cause.
So I got one more question, and I'll ask you to kind of maybe put on your prognosticator hat for a second. So what do you think, like where do you think this kind of work that you've done already is headed, or maybe just this sort of area of testing and distributed systems and failure modes and stuff like that? Like what are you excited about working on next, or where do you kind of see this going in the future?
Sure. So this is a really exciting area for me right now because I've been working on distributed systems for a while, but in terms of training, I was trained as a mathematician. So this wild, wild west of software can be a very scary place for me sometimes. And I'm excited that there's interest in ramping that down and really understanding these systems and how they run. So I'll share my thoughts in a second, but in terms of a high-level summary and writing, a couple months ago in ACMQ, Katie McCaffrey over at Twitter wrote a really excellent survey from the perspective of a practitioner about what sorts of techniques are out there and what sorts of techniques might be underutilized in understanding distributed systems. So, frankly, I think there's still a lot of low-hanging fruit in terms of testing all of these systems we've built just from a randomized black box perspective that acknowledges the reality of failure conditions. But on top of that, there's really great research from Peter Overo about lineage-driven fault injection that does a more targeted exploration of these different failure spaces. There's really cool stuff out there from a more academic perspective where we either use something like a TLA plus driven proof system to actually prove properties, which has a huge learning curve, and I think a lot of people are still trying to navigate how they might use it in actually building software, or to kind of slide down that ladder of rigor. There's either exhaustive or targeted model checking, so we're working at an algorithmic level and understanding it. And some of those, I don't know how much I'll be able to bring them into, or anyone for that matter, can really bring them into what they're doing tomorrow. But I think they can take a lot of inspiration in those, in how they design their testing frameworks and how they try to explore the state space of their software.
Awesome. Okay, well, I think we're running pretty close to time here. Joel, you said you had you have a talk coming up that you did want to mention.
Yeah. So I'll be talking about a lot of these same things in more detail about Jepsen testing Cassandra at Devox in London. That's June 8th or June 9th will be my talk. I'm not sure which one. Maybe there will be time for a live demo. If not, track me down after. I'd love to give you one. I'd love to talk about it. One last note. I know we're short on time, but I have to sneak this in. I think there's also a perception that things like Jepsen and styles of testing like Jepsen are only important to people who are writing databases. And look, I won't argue they aren't important to us. They definitely are. They help me do my job. But I'd also encourage people to really look at that testing when they're testing their own systems they're building on top of Cassandra or any other distributed system, because they might not realize it, but they're probably building a distributed system too, and they should also carefully consider their invariants and how they want to preserve them.
Yeah, agree 1,000%. Especially these days with the whole microservices thing being sort of the trend as far as architectures go. Like, yeah, you're right. A lot of people at the system level, not just the database level, are dealing with distributed systems in their data centers. So it's super important. Yep.
Wow. Yeah, there's no doubt. Complex things fail in complex ways. I say that all the time, and we're not building less complex software anymore.
Yeah, that's one of the things is. As exciting as some of this research and algorithmic analysis is, a lot of those guarantees aren't really compositional in a clear way. So that sort of actual black box systems testing is one of the most effective ways to increase confidence.
Well, Joel, I really appreciate you coming on today. It was kind of late notice when I pinged you on this, but I'll tell you, personally, I'm one of your biggest fans. I'm like having a little star moment here, so I'm glad you could come on. I would love for you to come back too, because this would be great. I should also mention you're going to be at the Cassandra Summit, I'm sure.
Yes.
If you haven't seen one of Joel's talks, and probably haven't, but you will. You should watch it. The slides alone are worth the price of admission.
All right, thanks, Joel. We'll wrap it up now. Thanks, everybody, for tuning in, and we will see you next week on This Week in Cassandra.